Okay, questions 3 and 4. Questions 3 and 4 we'll do together because it's the same gear train that we're talking about and it's more concepts. So the first thing it talks about is gear. If gear A is the driver, so this is driving, however it's driving, whichever direction, which gear train does this not increase? And the idea is that our equations are always n output over n input, or whatever, for a gear ratio over 1, but it's always flipped for the input for omega over the output for omega. Okay, so this has more teeth than that. C is bigger than A. Okay, and we can jump right across from A to C. If you haven't paid attention to that before, you can jump across when you're getting gear ratio. In this case, it's not a compound. But the idea is this. So C has a bigger gear ratio, right? So even if we just assume, let's say that C had 30 teeth, all right? So let's do 30 here. So if I had 30 teeth for C and A had 10, we know for sure that your gear ratio is going to be bigger, and in this case, gear ratio will be equal to 3 over 1, which means you'll have more teeth than A. You also will have more torque because it's torque output over torque input. All right, so you'll have more torque for C than A. The only thing that changes is, or goes down, is our RPMs, which is the same as angular speed. So angular speed is the only thing that would actually go down with this gear train and not go up. Okay, now the next one is gear A, gear, so it's the same thing. Why would we have B here? Okay, especially because B has no change in teeth, but even if it doesn't, we've said that you can jump across from A to C for a gear ratio in a simple gear train like this. Well, the reason is this. Right now, if A is spinning, let's say clockwise, that means B would be spinning counterclockwise. And if B is spinning counterclockwise, that means C is spinning clockwise. All right, CW, CW, CCW. All right. So what happens is we have these are idler gears, and the idler gear is there to change the direction so that C can go in the opposite direction than what we want to do. There you go.